Okay, so let's do a couple more examples. So example 2. And yeah, we're just calculating derivatives. So d dx. And we have something like this. So 3x minus 2x squared. And that's raised to the 5th power. And yeah, that's it. So you guys can 5. You guys can try to do it on your own, or you can pause the video and try it. And yeah, so we have the outside function, right? So that the outside function is that, right, the parentheses, and then that 5th power exponent. So that 5 will go to the front, and then we have the inside function unchanged. So 3x minus 2x squared. And then this is, right, this is less by 1, right? I subtracted 1. And now we multiply it by the derivative of the inside, right? So here's the inside. So 3x minus 2x squared. Okay, so derivative of that would be 3 minus 4x. All right, and that's the answer. Okay, so I don't know, we'll do more, obviously. So example 3. And yeah, so this time we have so square root of 3x plus 1. Yeah, and that's the function we need to take a derivative of. Okay, so the first thing we'll do is rewrite that square root in the exponential form. So we'll have, let's do it this way. So 3x minus 1, right? So that's to the 1 over 2 power. And then now we're still taking derivative of that. Okay, so derivative of the outside. So the outside is that half. So that half will be in the front. And then we have the inside unchanged. So 3x minus 1. And then half, right? So I'm subtracting that 1, right, from over here, from that half, right? So half minus 1 is negative half. And then the last thing, right, we take a derivative of that inside. Okay, so times 3. Okay, derivative of 3x is 3, derivative of 1, or negative 1, is 0. Okay, and yeah, so let's write the final answer. So that would be, maybe, right, so that negative in the exponent, right, this one, right, it's going to push the whole thing into the denominator, right, that, but only this, right, so this expression is under that negative exponent. So I'll have, right, square root of 3x minus 1, because, right, that square root didn't go anywhere, right? It's just that negative in front of it pushed it to the bottom, right? So 3 is on the top, and that 2 is on the bottom. Okay, so that's the final answer. Okay, yeah, so we could come up with some kind of general power rule. Right, so before we had just some power rule, right? So this is, let me maybe let's do it this way, or this way, this color, right? So power rule, when something like this, right? So I had x to the nth, and I'm taking derivative of that, right? So that will be n in the front, and then x n minus 1. Right? So this is just a power rule. So now we have a general power rule. So instead of that x, we'll actually have a function. So it's going to look like this. So we have d dx. It's kind of similar to what I showed you before. So u to the nth. Right, so we have that. Okay, let me I wonder if I can move it. I think I've done it before. Here you go. I figured it out. Anyway. Okay, so that n goes to the front. So I have n times u, and that u is unchanged inside function. And then lastly, we multiply it by derivative of that inside function with respect to x. Okay, so yeah, let's do a couple more examples. So maybe one with trigonometric functions. So example 4. So we have d dx of sine of 6x. Okay, so right, so this is the outside function, and this is the inside function. Okay. Yeah, so when we calculate derivative, first we look at that sine, right? So derivative of sine is cosine. So I'm going to write cosine. And then I put the inside unchanged, so 6x. Right, so you understand that 6x is under that cosine, right? And then derivative of the inside, so that's 6. Right, so if we want to write it maybe in more elegant form, so 6 cosine of 6x. Okay, so that's the final answer. Okay, so yeah, let's do a couple more. What do I have here? Yeah, a couple more examples, and then and then more examples. Anyway, and then, well, of course, there are like some practice problems for you too. So example 5, and this one, so we're given a function f of x equals x squared, and then square root of 5 minus x squared. So given this, find the derivative. Add 1, 2. Okay. Yeah, so we need to, calculate. We have a function. We need to calculate the derivative. So f prime of x. Okay, and you guys see that there is multiplication, right? So I have x squared times that radical. So I need to use the product rule. Okay, so that was derivative of the, let me write it slowly. Okay, so I have, and I'll use those primes to indicate that we need to differentiate that expression. Okay, so times the second expression unchanged, 5 minus x squared. Okay, then I have plus, the first expression unchanged, and now I need to do a derivative of that radical. Okay, so 5 minus x squared. And at this point, what I'll do, I'll change that radical to so it's a square root, so that's going to be a power of half, right? Exponent of 1 over 2. So 5 minus x squared, and then we have that half, okay? And yeah, we need to take a derivative of this one. Okay, so that will be equal to, so derivative of x squared is 2x. And then we have that radical 5 minus x squared. Then plus, so here we have x squared. And then I need to take a derivative of this right, composition function, right? I'm talking about this whole thing. Okay, so here we go. So half to the front, right? Then 5, which my 2's are not perfect. There's nothing. I write this perfect. Yeah, but 2's are particularly bad. Anyway, 5 minus x squared. Now again, I'm subtracting 1, so negative 1 over 2. No, this is a nice 2. Okay, so times derivative of the inside. Right? So that's, inside is this. Okay, so derivative of that is negative 2x. Okay, so negative 2x. Okay, so yeah, we have this long solution, long answer. Maybe we can simplify it a little bit. So we'll have okay, that 2x. Right? At first, I cannot really do much with this one, right? With this part. So I have the 2x. Then we have 5 minus x squared. Now we have plus. And now here we have x to the second power and then x. So that's going to be x to the third power. Also, I have this minus here. Right? So that's going to make that sign negative. So x to the third. Then we have 2, right, and half. Half of 2 is just 1. Okay, so then we have times, and yeah, let me just write it as radical. The problem is that it's that negative, so maybe let's write it this way. Right, so we have 1 over what is it? 5 minus radical square root of 5 minus x squared. Okay, I hope it's right. I think it's right. Okay, so we've taken a derivative, so that's the derivative, but that's not really what we need to do, right? We need to figure out. There was a derivative at a specific point. So you can think about it. It's the same thing as if you were graphing that curve, this one, right? Graphing the original function, right? And then there would be a tangent line at this point, and you would be finding or looking for a slope of that tangent line to the graph at that particular point, right? So it's the same thing that we're doing, right? We're finding a derivative at that specific point. Okay, so where are we? We're not. Right, so I have this. This is the derivative. So now I need to evaluate the derivative for 1, right? So x is 1. So f prime of 1, right? So it's going to be 2 times 1. Here we have radical 5 minus 1 squared. I'm writing too big. I won't be able to fit it. Let's see. Maybe if I shorten this a little bit. Okay, so now we have minus, so 1 to the third, and then we have 1 and square root of 5 minus 1 squared. Okay, so so what is it? Do I need to do this arithmetic? Let's do it. Why not? Okay, so we have 2 out of that first. 2 times 1, and then we have, I'm looking at this, what is that? Looks like 5 minus 1, so square root of 4 is 2, so 2 times 2, and then we have minus 1, right, so I'm looking at this thing, so 1 over square root of 4, so that's also 2, so it's going to be 1 over 2, so 4 minus half, that's 7 over 2. Okay, so this is our final answer. So derivative, right, of that function that we saw at the beginning at that point is 7 over 2, right, or this slope of the tangent line at that point to the graph. Okay, we can have more examples. Example 5. And it goes like this. So d dx. And then we have sine to the third, and then 4x. Okay, so let me rewrite it. Again, maybe we can move that. Okay, so I hope you know that this 3, right, that exponent basically refers to the whole function, right? So it's d dx. Then I have sine of 4x. And now this entire function is to the third power. All right, so you see that we have a couple things going on, right? So this is, well, meaning that we actually have 3 different functions put together. All right, so that's the most outside. Then we have sine, right? And the most inside function is that 4x. Right, so we have to use that chain rule twice. All right, so let's try it. Let's do it. Okay, so that 3 is going to go to the front, and I'm going to subtract 1 from it. All right, so it's going to look like this. 3. Then I'm rewriting the whole thing, right? I'm not really touching it. So sine of 4x. Right, and now let's do the second power. Okay, so now I need to multiply it by the derivative of the inside. So let me do it slowly. Okay, so I have that sine of 4x. And I'm taking derivative of this. Okay, so here we have 3. And at this point, right, I'm here. I'm rewriting this. I'm going to take that 2 and put it right there. And it's kind of the industry standard, right? So we have sine square 4x. Okay, so now I'm taking derivative of that, of this one. And this time I'll do it in one step, right? Because, right, this is just 2 functions put together. Okay, so derivative of the outside, right? That's my outside in this particular part of the problem. is going to be cosine. So cosine 4x. And now at the end, right, I'm taking derivative of this, right, of the inside. So times 4. Okay, let me do it this way. Okay. So the final answer, and I can combine these two, right? So I can take 3 and multiply by 4, right? So that's going to be 12. So 12 times sine square 4x times cosine of 4x. Alright, so this is the final answer. Okay, so here's another example. This one is example 6. And again, right, you guys should try to do it on your own. So f of x equals sine square x plus cosine square x. So think about this one, right? What do you think that should be, right? What do you think this is? Anyway, let me rewrite it so that we can see it better, right? So that 2 is over here plus cosine x, and again, right, that 2 is on the outside. Right? These are our outside functions. So we'll have 2 to the front, and then sine x. I'm just, maybe I'll write it down there. Okay, so one more time. So 2 sine x, right? So my inside function doesn't change. Now times derivative of the inside, so cosine x. I subtract 1 from 2, so I get 1. And then plus 2 cosine x times derivative of cosine, so that's negative sine x. Okay, so we get 2 sine x, 2 sine x, cosine x minus 2 sine x, cosine x. Alright, so we get 0. But you guys already knew that, right? Well, why is derivative of this equal to 0? Well, sine square plus cosine square is just 1, right? So if this is 1, derivative of 1, which is a constant, is 0. Okay, so here I promised you problems to practice. So here they are. So problems. And yeah, here we go, the first one. Yeah, so you're just calculating derivative, right? We're not doing anything fancy. Oh, actually, in one, we do. Okay, 4x minus 1 to the third. Problem 2. So this one is radical 5 minus t. Right, then you guys need to calculate derivative. Problem number 3. So f of x equals tangent square x minus secant square x. I don't like that 2 as usual, so let me fix that. Okay, so figured that one out. And now number 5. There are 6 problems. Wait, something's not right. Okay, so this is actually problem, hold on. so I'm trying to move that. Okay, that's good. So problem 3 looks like this. So f of x, and then we have sine, and then the inside function is tangent of 2x. Okay, so this is problem 4. Problem 5. Right, so that's like the problem that we did a couple of minutes ago. So find the equation of the tangent line. Equation of the tangent line. Tangent line to the graph. Right, so this time you're not only finding the slope as we did before, right? We found derivative at a certain point, so that's the slope. But here you also need to find the rest of the equation. To the graph of, here's the function. So 26 minus secant to the third of 4x. And the point is 0, 25. Okay, so that's problem number 5. Problem number 6. This one here, you're just finding the derivative. Okay, so it looks like this. So 3x minus 1 on the top. And the bottom is x squared plus 3. And that whole thing is to the second power. Okay. Yeah, so let me give you the answers. And the first one is 12, 4x minus 1. And then this is to the second power, right? And now number 2. Number 2 is negative 1. By the way, right, so this is a prime, right? This is not 1. I was just looking at it and thinking, why is there 1? Anyway, negative 1 on the top, and then 2. 5 minus t. Okay, so that's the second one. The third one is 2 secant squared. 2x. And then we have cosine. Tangent 2x. Okay, number 4. The answer is 0. Number 5. I'll give you the answer here. So that derivative will be negative 12 secant 4x, secant to the third, 4x, and then the equation of the line is 25. Right, so don't forget, you need to show work, you need to actually do the problems. And solution for number 6 goes like this. So negative 2, 3x minus 1. And then we have a quadratic expression, 3x squared minus 2x minus 9. And then the bottom is x squared plus 3 to the third power. Okay, and then, yeah. So we'll continue with with the examples. Right, so this one, example 8. So this time we need to find the second derivative. So find f double prime of x if f of x is equal 1 over 2x minus 6. Okay, so let's start with the first derivative, and that is let's just do f prime of x, and I'm going to take my function, I'm going to rewrite it like this. So it's going to be 2x minus 6, right? And now, because right, so this was in the denominator, so now I want to move it into numerator into just regular level. So -1, right? And taking derivative of the entire thing. Okay. Yeah, so right, so we need to use chain rule, right? So my outside function is that -1, so that -1 will be in the front, and then I'll write 2x minus 6. Okay, so I subtracted 1 from the -1, so that's going to be -2. And now I need to multiply it by the derivative of the inside, so that's going to be times 2. Okay, so let me clean it up a little bit. So that's going to be 2. And then I have that, or actually, wait. Yeah, it's -2. So -2, and then we have that 2x minus 6. Minus 6. And the exponent is -2. Alright, so this is my first derivative. So now I need to take the second derivative. So I have double prime of x. Alright, so I do that -2. I'm just going to rewrite it. 2x minus 6 to -2, right? And we're taking derivative of that. Okay, so yeah, that's gonna be this -2 to the front. So we'll get +4. Okay, so I have 4. I'm rewriting the inside, 2x minus 6. Now the outside, right, the exponent, right, so I'm here. The exponent will be -3 because I'm subtracting 1. And then times derivative of the inside, so times 2. Okay, so the final answer will be 8 on the top. Now we'll have 2x minus 6, and that's the third power. Okay, so that's my final answer.